To produce steam, you need heat. Plant boilers rely on the process of combustion to generate this heat. To generate heat and produce steam efficiently, boilers need the proper combustion equipment, devices like burners and stokers. Safe and cost-effective steam production also requires careful control of the various boiler flow paths. For example, boiler operators need to monitor and control air, water, and steam flow. The main function of all burners is the same: to inject a mixture of fuel and air into the boiler's combustion area. Burners are used with fuels that mix easily with air, such as natural gas, oil, or pulverized coal. This burner, for example, is a typical gas burner. It uses dampers or registers to regulate the amount of air entering the burner. Pipes called spuds inject natural gas into the boiler. This is an impeller. It's basically a stationary plate with openings, or vanes, that cause the air to swirl around and thoroughly mix with the gas. An igniter starts the gas-air mixture burning. This one has a sparking device that uses electrical current to create a spark across a pair of electrodes. The spark ignites the gas-air mixture. As it burns, it provides heat for the boiler. Like all fuel burners, oil burners provide a means to mix fuel and air for combustion. But there are some important ways in which oil burners are unique. This shows the major parts of a typical oil burner. Dampers control airflow into the burner. This is an impeller. It's basically a stationary plate with openings or vanes that cause the air to swirl around and thoroughly mix with the oil. Since oil's a liquid, it has to be changed into a mist or atomized before it can mix well with air and burn. This example is a mechanical atomizer. Mechanical atomizers depend on the pressure of oil passing through a nozzle to produce a fine mist. Fuel entering the atomizer flows to a sprayer head. The oil is forced through the nozzle, which breaks the oil into droplets. The droplets are sprayed into the combustion area in the form of a fine mist. Here's a type of atomizer that can use either steam or air to atomize oil. Steam or air flows through a tube and then to a nozzle in the sprayer head. Oil is supplied through the atomizer to the sprayer head, which directs the oil into the path of the high-velocity steam or air. This breaks the oil into a fog-like mist as it enters the combustion area. This action makes the oil easier to ignite and burn. To start the oil mist burning, there's an igniter. This igniter consists of a sparking device and a separate atomizer which serves as a pilot for the burner. A small amount of oil is sent to the igniter atomizer. The oil flows through a nozzle which creates the mist. The spark ignites the oil mist. After a flame is established at the igniter, oil flow to the main atomizer is started, producing an oil mist. Then the igniter flame ignites the oil mist and the combustion process begins. Some boilers are designed to burn solid lumps of coal. A device that supplies and burns lumps of coal is called a stoker. Stokers can also burn wood chips or other solid fuels as well. This stoker has a series of grates to hold the coal. A drive mechanism moves the grates through the combustion area of the boiler. The coal is stored in a hopper. A gate controls the amount of coal fed to the grates. As the coal moves along, air is forced up through the grates to provide the oxygen needed for combustion. The burning coal moves through the boiler's combustion area and supplies the heat needed to produce steam in the tubes surrounding the combustion area. Coal ash falls off the grates into an ash bin. In this topic, we saw the major types of boiler combustion equipment. We looked at gas burners, oil burners, and stokers. The airflow into a boiler provides oxygen for combustion. Gases produced during combustion flow out of the boiler and are discharged from the stack. The flow of air and other gases through a boiler is referred to as draft. The components typically used to provide draft are fans. There are two basic categories of draft fans: forced draft fans and induced draft fans. As their name implies, forced draft fans force air into the boiler. A forced draft fan draws air from outside the boiler and forces it through the burner into the combustion area. Induced draft fans create draft by drawing combustion gases from the boiler. Many boilers operate with only a forced draft fan. However, some boilers need both types to provide the proper draft. For example, in this boiler, the forced draft fan supplies air to the burner. Then, the induced draft fan draws out the hot combustion gases. The demand for steam from a boiler is called boiler load or steam load. When boiler load increases, more fuel must be burned to produce more steam. When boiler load decreases, less fuel must be burned. Changes in boiler load also require changes in the airflow to the boiler. The mixture of fuel and air supplied to a boiler is called the fuel-to-air ratio. It's important to maintain the proper fuel-to-air ratio to avoid combustion problems. For example, if the boiler is not getting enough air, some of the fuel entering the boiler won't burn. Instead, it may get carried out with the combustion gases and wasted. In some cases, unburned fuel could build up in the boiler. This buildup could cause an explosion if the fuel were ignited. In oil-fired boilers, unburned fuel may create soot deposits that coat boiler tube surfaces. Soot buildup interferes with heat transfer and reduces the boiler's ability to produce steam. In extreme cases, you may also see black smoke coming from the stack of an oil-burning boiler that's not getting enough air. On the other hand, if a boiler gets too much air, some of the fuel is used up to heat the extra air. This heat flows out of the boiler with the combustion gases. As a result, there's less heat available to produce steam. Most boiler operating procedures specify the proper fuel-to-air ratio. In addition, many boiler control systems automatically adjust the fuel and air mixture as boiler load changes.